Okay, here the recording in progress. So share the screen. Okay, so we are here. I'll give you the quiz in just a moment. And we have plenty of time to finish everything we need to for the test. Today's section actually will not be that long, or session will not be that long. I'll lecture only for a little bit about some more problems from 3.5. And then I have all of next week to finish 3.5 and then do 3.6. I got a lot of buffer days. Okay. So that's what we're up against. So next week, test on Friday. Coverage is here. Okay. Please note the adjusted homework assignment for 3.5. Skip problem 11 and 23 on. I'll do a lot of these problems today. Monday, I'll finish 3.5, and then I have the rest of the week to do 3.6. So you're responsible for this material for the test. Usual rules apply. You've already had a couple of exams with me, so you know what it's all about now. Turn in this homework, 70% homework requirement, but that's really a joke since I do a great percentage anyway. Sometimes I literally do 70% or more of the homework. So that's not that big a deal. If you haven't already done so, start working on your cheat sheet, formula sheet, front and back, anything that you want, 8.5 by 11 size, and so on. Okay, and then the next topic after that is trig. As you can see, there's a big chapter because we're reviewing a lot of our trigonometry. You'll definitely need trigonometry when you get to calculus for that. But that would be the third test, and believe it or not, next test is the third test out of 6. So that would already be the halfway mark. We'd be halfway through the semester already after the test. Actually, not quite. It'd be 8 out of 17. So close to halfway, but not quite. Please notice there's also a flex day, a CSM flex day on Wednesday the 13th. No school for students. Teachers have meetings, but you don't have any classes, not just my class, but if you have any other classes at CSM, they're all canceled also for a flex day. Okay, so here we go with the quiz now. So get ready to take a picture on your cell phone or do a screenshot, or you can just look at the video later of the quiz. And move this over. Try to raise it up a little. Okay, so number 1, give the domain of the function f of x is the square root of x plus 3, x minus 1, x minus 5. That's just like stuff we did yesterday. Okay, so the trick is to make the stuff underneath the square root greater than or equal to 0, right? So do your sign chart, set down the zeros of the function as your boundary points, and then region 1, region 2, region 3, region 4, etc. Determine the regions which are true and which are false. And I think I'm giving you too many hints as it is already. So that's what you do for number 1. Okay, if you're not sure what to do, look at what we did yesterday or look back at the video there. So all that stuff under the square root, greater than or equal to 0. Do your sign chart, lay down certain points on the number line, pick a point in each region and so forth. Okay, number 2, let me make it a little bit higher up so you can see. Number 2, the function is x squared minus 9 over x squared plus 7x plus 12. Sketch the graph, give important information like the intercepts, right? Domain, ha and va, horizontal asymptotes, vertical asymptotes, and so on. There is a hint, there will be a hole in the graph. And I think I can see why. Yeah, you factor the top, x squared minus 9. You factor the bottom, x squared plus 7x plus 12, and then something cancels out. So from that cancellation, you can determine the hole. And that means, let's see, after you do it, you should have only one vertical asymptote, one va, because after you factor the bottom, right? Again, I'm giving you too many hints, but factor this out, you get a cancellation. So you aren't going to have 2 vertical asymptotes, only 1 vertical asymptote. And you should be able to determine a horizontal asymptote. That should be pretty straightforward. And then do the analysis of what happens when I get close on the left and the right side of the asymptote, right? So pick a number a little bit to the left of the vertical asymptote, pick a number a little bit to the right of the vertical asymptote, and go from there, sketch the graph. And they're telling you there's a hole because of a cancellation. Okay, so I'm raising it up. In case you can't see it, I'll read it again. So number 1, give the domain f of x is the square root of x plus 3, x minus 1, x minus 5, x plus 3, x minus 1, x minus 5. So the trick is all of this stuff has to be greater than or equal to 0, is what we said. Number 2, in case you can't read it, graph f of x is x squared minus 9 over x squared plus 7x plus 12. Factor the top, factor the bottom. You should get a cancellation. That cancellation is going to lead you to a hole. So there should be a hole in the graph. But after that, do the other analysis of vertical asymptote, horizontal asymptote, right? End behavior, which is part of horizontal asymptote. And pick a number a little bit to the left and a little bit to the right of the vertical asymptote. So you can tell, is the graph going up to infinity or going to negative infinity, and so on. Okay, so I think that should be more than enough hints for the quiz, due at 11:59 p.m. So you have more than half a day. For those of you that are with me in the Zoom meeting, those of you that aren't here at the Zoom meeting, you're just looking at the video later, you'll get this, later in an hour or a couple hours, but you still have plenty of time to do it, hopefully. Open everything, open book, open note, and so forth. Okay, I'm going to put this away in a second, but does anybody have any questions about the quiz before I go on with the material? And yeah, we were going to end fairly early today, so you can get started on working on it. So any questions about the quiz? Hopefully I've given you enough hints as to how to do it. Or just look back at the stuff we've done the last few days, and that should do it. Okay. All right, I don't hear any questions, so I'll put it away. You can ask a question later. But let me do today's material, which will not be that long. We are more than likely going to finish very early, so I can give you enough time to get started with the quiz. Okay, so quiz is being put away. I have done everything I wanted to show you for this. 3.5, page 175. Right? In fact, I'm just looking at question 5 or 6. It's very much like the quiz question. So if you look at what we did for number 5, that just mimic almost identical to the quiz question. Okay. And then the rest of this section, 13 to 21, sketch the graph and label the axis, intercepts, and asymptotes. Okay, so I'll do maybe 3 of these, and that was all I was going to do for today. Okay. And then, yeah, we only have one more section on complex roots. So we're back to doing the I stuff. Remember, I is the square root of -1, or I squared equals -1. So back to complex numbers. We did some of that, hopefully, in intermediate algebra. So we'll resurrect that topic for next week, and then leading up to the test on Friday. Okay, so let me do some of these problems that are here. All right, so first, the topic of rational exponents. Again, ignore any dates that are here. A to the B over C. If you have a fractional exponent, it means this is the power, this is the root. So it means take the C root of A and raise to the B power. Or you could do the power first. A to the B power, and then do the C's root. So you do the power and then the root, or the root and then the power. If you have real numbers, it's normally easier to do the root first. So this is a little bit clumsier to write because you have to write parentheses. This one you don't have to write parentheses. But in actually computating these, it's usually easier to do this because when you take a root, the number usually gets smaller. And we like smaller stuff. But when you take a power, normally it gets bigger. So this is easier to write, but normally it's easier to write it like so. Okay. So A to the B over C. The number on top is a power, number on bottom is a root. Put this in your cheat sheet if you want. If we were meeting face to face, I'd make you memorize it. The memory trick I have is the root of a tree, the root of a plant is further down, right? So I notice that the C is down, the root is down, so that's the root, therefore this is the power. Okay, so some quick examples. And this should be reviewed. You should have seen this already in intermediate algebra. 8 to the 2/3 power. Right? This is the power, this is the root. So I do the cube root of 8, and then I square it. Okay. And what is the cube root of 8? 2. 2 squared is 4. Or you could square first, that usually makes the number bigger. 8 squared first is 64. And then the cube root of 64. What number times itself 3 times will give me 64? That is 4, because 4 cubed, 4 times 4 times 4 is 64. Okay. This way we had to deal with a much larger number, right? We had to go all the way up to 64. So usually it's easier to do the root first and then you square. Here's another example. 81 to the 3/4. Power root. You could start off with this, 4th root of 81 cubed. I don't really want to do 81 cubed. 81 times 81 times 81 is some super big number. I think I'd rather do the 4th root of 81 first and then cube it. 4th root of 81, it's actually not that bad. It's 3, because 3 to the 4th power is 81. 3 is a number whereby if I raise it to the 4th power, 3 times 3 times 3 times 3, I get 81. So this is 3, and then I cube it. So 3 cubed, 3 times 3 times 3, 27. All right, with that background, now problem 13 from 3.5. They want me to graph f of x equals x to the 3/2 minus 2. All right. So x to the 3/2 means square root of x cubed, or you can do the square root of x first and then cube. All right, so how do I graph such a crazy thing like that? First, let's realize for real numbers, I can only plug in 0 and positive quantities, non-negatives. So I'm only going to plug in stuff that have nice square roots, no negatives. Okay. We will get square roots of negatives in the next section, the last section, 3.6, which is on complex numbers. Okay, so we'll get that, but we're not there yet. That's on page 177. We're trying to knock off these problems on 176. Square root of x. So I just picked numbers like 0, 1, and 4. Why 0, 1, and 4? They're nice square roots. I didn't pick 2 because that's not a nice square root. I didn't pick 3 because that's not a nice square root. Okay? I just want a quick and dirty graph. I'm not allowed to plug in any negatives. Okay, so I plug in 0. Square root of 0 is 0. 0 cubed is still 0. Plug in 1. Square root of 1 is 1. 1 cubed is 1. Square root of 4 is 2. 2 cubed, 2 times 2 times 2, 8. Okay, so rough sketch of the graph of x to the 3/2 power. So I made myself a little chart. 0, 0, 1, 1, 4, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8 is here. So the red graph is x to the 3/2. Curves up. Nothing over here. All right, and then I think you might recall what happens when I put the -2. Just shove the graph down 2 units. Same general shape. So 0, 0 becomes 0, -2, and just go like that. So the green is the answer for the graph, but it does ask me for some of this other stuff. Give any intercepts and asymptotes. Well, this graph does not have any asymptotes. We do not approach any line. This just shoots up. So no asymptotes. How about intercepts? Well, if I plug in 0, I get -2. 0, -2, we already know that. A little bit harder to find the x-intercept. X-intercept means plug in y as 0. So it touches here somewhere, so where is there, right? The way I drew it, it looks like it might be 3, but it really isn't. Okay, I'm just guesstimating here. So I plug in 0 for y. 0 equals x to the 3/2 minus 2. Add 2 to both sides. 2 equals x to the 3/2. Then you say, how do you get rid of the 3/2? Raise both sides to the 2/3 power. Excuse me. Okay, so 3/2, 2/3, they cancel out. So x is 2 to the 2/3 power, not very nice, as you can see. It does mean you square the 2, 4, and you take the cube root. So cube root of 4, comma 0 is also an intercept. All right, so there's the graph. Where does it touch the y-axis? At 0, -2. Where does it touch the x-axis? At cube root of 4, comma 0. And, you know, we'll just leave it like that. And we could get a decimal approximation, I suppose. So let me just try it. 4 raised to the 1/3 power. About 1.59 is the cube root of 4. So actually, I was way off. It looks like I came over here to 3. It should be more like over here. But anyway, we don't know that ahead of time. So we'll just leave it as such. Okay. All right, so that's 13. 15. X minus 1 to the 1/3 power plus 1. That is just a translation of x to the 1/3 plus 1. And we know x to the 1/3 means cube root. And the translation, which means move, is 1 to the right and 1 up. Okay, so let me draw the progression for that one. Okay, x to the 1/3 in red means cube root of x. So in red is the cube root function, supposedly. 0, 0, 1, 1. This is supposed to be 8, 2. I know the cube root of 8 is 2, so I went 1, 2, 3, 4, 5, 6, 7, 8, 2. And -1, 1, -8, -2, -1, 2, 3, 4, 5, 6, 7, 8, -2. So if you can follow in red, that's the cube root function. And then right 1, up 1. So 0, 0 becomes 1, 1. And then I just draw the same basic shape. So the green is the actual graph that I want. Okay, I'll let you figure out the intercepts from there. But if you plug in 0, let's see, 0, oh, 0, you get 0. Right? Because -1 to the 1/3 cube root of -1 is -1. Add 1, you get 0. Okay, and we know the cubic function is a 1-to-1 function. So yeah, it touches 0, 0, and nowhere else. And again, it looks like there's not going to be any asymptotes. So that is that. Okay, 17. And then I was going to be done. Okay, 17 is a little bit harder. -2 times x plus 1 to 2/3 minus 2. Again, skip 23 and on. I'm not going to have you do any of these weird ones. So let me start off with x to the 2/3. X to the 2/3. Yes, there's a -2 I have to worry about. There's a translation of 1 to the left and 2 down. We'll get that in just a moment. All right, y equals x to the 2/3. This is the power. This is the root. So it's the cube root of x squared. Or you can say it's the cube root of x and you square it. This turns out to be an even function. If I plug in a positive quantity or a negative quantity, I get the same thing. So whatever this thing looks like, let's see what I kind of have there. I should have symmetry with respect to the y-axis. All right, so 0, 0. You know, how did I come up with these numbers? I picked numbers that have nice cube roots because I know I have to take cube root of something. Okay, plus or minus 1. Cube root of 1 is 1. Cube root of -1 is -1, but when you square it, you get 1. Plus or minus 8. Cube root of 8 is 2. Cube root of -8 is -2. In either case, when you square it, you get 4. Plus or minus 27. Cube root of 27 is 3. Cube root of -27 is -3. In both cases, when you square it, you get 9. Okay, so I didn't feel like going out to the 27 one, but because I got up to 8, so 0, 0, 1, 1, 8, 4, and here's -8, 4. Okay, so this red graph is x to the 2/3. The green is -2 x to the 2/3, which means it's reflected across the x-axis, but steeper. So this shoots down more steep than x to the 2/3 because there's a coefficient of -2. Okay, the negative means it goes down. If it was a positive 2, I'd make it kind of go like that. Maybe I should do this. This would be 2x to the 2/3. Yeah, I should show you that. And then -2 x to the 2/3 looks like so. All right, then I do my translation. Translate means to move. So 1 to the left, 2 down, 1 left and 2 down. So, all right, I was at the origin. I end up at -1, -2. So finally, here is the graph that I want. So this is the final graph. -2 times x plus 1 to the 2/3 minus 2. And as far as intercepts is concerned, well, there's no x-intercept. Okay, the final graph is this one. It does not touch the x-axis. It looks like it does touch the y-axis. And where does it touch? Just plug in x is 0. So put a 0 here. 0 plus 1 is 1. 1 raised to anything is 1. Times -2 is -2. -2 minus 2 is -4. So the y-intercept is 0, -4. And that's it. And once again, it looks like there's no asymptote. So we'll just leave it like such. All right, and that is all I was going to do, folks. Finished with a lot of time left over. So Monday, I was going to knock off the rest of this section. I have 21 to show you. So I'll do that Monday, and then we just have one last section for the test, 3.6, complex roots of polynomials. So we'll review the I concept, right? I is not a real number, square root of -1, or I squared equals -1. So we have the so-called complex numbers, z equals a plus bi. This is the real part. This is the imaginary part. Okay. And what we're up against is this. Okay, so some work. This is sort of like what you had in intermediate algebra, right? Some algebra involving I, adding, subtracting, multiplying, and dividing with I. Okay. And then we're finding roots of polynomials once again, except sometimes they end up having complex numbers. And how do we get complex numbers? When you try the quadratic formula, you take a square root of a negative, right? So we're back to doing this stuff again, solving polynomials, right? All this stuff, except they're telling us some of them there's going to be i's. Actually, they already tell us that there's some i's in here for some of the solutions. So that's what we're up against leading up to the exam next Friday. Okay, so schedule-wise, not quite, but I'm almost done with 3.5. I had one more problem to show you there, and then we have the rest of the week to finish 3.6, and we have plenty of time to do that, I think. Okay. All right, so that was it, folks. I was going to let you get started on working on the quiz. And let me check the chat. So let me stop the share and see if anybody has any questions. Otherwise, I'll let you loose to get going on the quiz due at 11:59 p.m. tonight, which means you have more than half a day. Those of you that are with me right now, those of you getting the video later, you have a little bit less time. You have to wait for the video, of course, but you still should have plenty of time. Okay, so let me check the chat real quickly. I don't see anything there. All right, so anybody have a question? Otherwise, that's it. All right, so I'll turn you loose. Quiz is due at 11:59 p.m. tonight. Open everything, and then have a good weekend. All right, bye everybody. Have a good day. See you next time.
Thank you, Professor. Have a great one.
Thank you.
Thank you.
Professor Holm, I was wondering if you could re-explain number 15 because I was a little bit confused on that one.
Okay. Let's see. You're still here, Miss. I can do that. Okay, so I took the cube root function, x to the 1/3, which I already know looks like this. Basic cube root function. If not, you can plug in numbers. So 0, 0, 1, 1, 8, 2. The cube root of 8 is 2. -1, -1, -8, -2.
Oh, okay.
And then I just moved the whole graph one to the right and one up. So the green is what I ended up with.
Oh, okay.
Mhm.
Okay, that makes sense. Thank you.
All right, you're welcome.
Okay.
All right, have a good day.
Bye. You
Bye.
too.